Okay, so it begins with a drop of ocean temperatures near Australia and a rise near South America. Winds will then slacken because there's not that pressure difference between the hot and the cold areas. So the winds slacken, which means the the tropical air with all the moisture in it won't actually reach Australia, and it actually drops its rain over towards America, and that's why we end up in drought. Eventually, the situation does reverse, and then we move into La Nina, which I'll talk about soon. Um, so the droughts in Australia here, this is important, and not always caused by ENSO, but sometimes they are. The droughts can last about a year and can extend to the whole continent. And as you will be aware, because of our recent drought, the rural economy can be devastated by droughts. Fires are much increased in these years, dust storms, and land degradation on the whole occurs. They're not nice times. La Nina is the opposite. So La Nina is a time where there is very strong trade winds on the equator. This is caused by extreme warm weather above Australia near Papua New Guinea and very cool water off the coast of the Americas. And the warmer and the cooler it is, the stronger these winds become because they rush to fill in um, the void that the evaporating air leaves behind. So you can imagine hot air rises. So as that hot air rises, wind has to rush in beneath it, and that comes across the whole Pacific and creates this weather pattern. So it's the opposite of El Nino. The eastern Pacific surface temperature near America is lower, then the air pressure in the central Pacific is higher. So there's stronger trade winds which blow hot water across to Australia. Means there's less rain in the eastern Pacific and Americas, and there's much more rain for Australia, as you can see in that image. So here is the image for, I believe, 2012. So in 2012 here you can see that over by America there is very cold water. Very cold water off the coast of South and Central America, and there's warm water off the coast above Papua New Guinea and along the equator there, and that um, is where a lot of Australia's tropical cyclones originate from before they moved south in towards Australia. So you can see warm water near Australia, cold water near America. Now this was in 2012. Okay, that resulted in this. Okay, one of the wettest years in recent memory, 2012, and you can see here that some places have their highest on record average rainfall. You can see around Bairnsdale very much above average. And if anyone here remembers 2012, it looked a little bit like this. Okay? So very, very large floods on our rivers. I think this one is upstream on the Mitchell River, but I could be wrong. But huge floods because of this La Nina weather pattern. La Nina results in increased rainfall for Australia. So it's common in Australia for drought to end with flood, and that's usually because El Nino moves into La Nina. Flash floods occur after heavy rain, and catchments of extensive river systems. So, for example, the Mitchell River sets heavy rainfall around Mount Hotham and above Dargo. Then obviously we get floods down into Bairnsdale on the Mitchell River. Lots of effects of flooding here that you can read through. Yeah. One there that I guess is important is spread of disease, and that's quite topical. But if there is floodwaters, then things move around, especially things that you might not want to move around, that can increase disease. 400 million a year on average for flood damage in Australia. That's averaged out. Okay, so some years would be much more than that, like the recent floods in Townsville. But they do have an environmental benefit, so floods are needed. Floodplains like the Mitchell River that Bairnsdale sits on. And out in Lindeno, and the floodplains there are used to grow an awful lot of vegetables. The only reason that can occur is because floods deposit sediment and develop rich soils with lots of nutrients in them. And without the floods, uh, those riverbanks don't get the deposits of those rich soils. And so you think about the Snowy River, which has been dammed. And so the floodplains at the moment on the Snowy River are rich and fertile. There's lots of dairy farming out near Orbost. But because those floods are not regular anymore and they don't occur, we see that there are some pretty bad environmental effects from damming the Snowy River. The floodplains will lose their fertility, but also the estuaries around Milo do not open very regularly, and so they're constantly needing to be dug out and flushed out, otherwise they will become infertile and stagnant, and the fish in them will not be able to survive. So floods are important, but they are destructive to society. So I just wanted to recap both the Indian Ocean Dipole and the ENSO systems. So first of all, in Australia, increased rain can occur if there's a negative IOD, a negative Indian Ocean Dipole, or a La Nina event. So there's two ways that we might get increased rain. Negative IOD, warm water near Australia, or La Nina, where there's warm water near Australia. So whenever there's warm water close to Australia, this increases the evaporation and precipitation. Drought, on the other hand, where there's less rain, is a positive IOD and El Nino, and this is caused when there's cold water close to Australia because it doesn't evaporate. So I hope you've understood these concepts. There are plenty of videos linked in today's lesson plan on to different videos explaining these concepts even more. Make sure you have a very good understanding of El Nino, La Nina, and the Indian Ocean Dipole before we move on.